All right, so Mod 2, Unit 4, functions. This is more about the vocab, like what does it mean to be a function? How do you know something's not a function? Well, a function is a relation, um, but it's a special type of relation where every um, value from the domain, which normally is our x values. If you're thinking about how we had lines last unit, our x values were values that were in the domain, our y values were values in the range. So every value from the domain only is paired with one value from the range. Now, a relation, there could be an equation for our relation. We don't need an equation. The relation could be data that we've collected. Um, so it doesn't necessarily have to have have an equation that goes with it, but usually it does. It's more interesting. We're usually trying to find the equation a lot of times if we have that. So here's a graph. It is a relation, and it says, well, it actually tells us it's a function. It says, what is the domain and range of the function? So whenever you're asked this, what's the domain and range? The domain are all the x values that you would see on this graph. Do you see a point with an x value of 0? Yes, there's one right there. Is there a point with an x value of 1? Let me go up and look and see. Yeah, there is one. How about 1/2? Yeah. How about pi? Pi's over here. Is there a point that has pi as its x coordinate? Yeah. Yeah. In fact, every positive value of x, I can go over here. I would just have to go really, really high up, but there's a point on this line that has that value of x. There's every value of x over here is accounted for. Every value of x over here is also accounted for. They just are going farther and farther down, but they're going to be there. So every value of x is going to be is part of the domain. And likewise, every y coordinate is found on this graph. There's a y coordinate of 10 way up here. There's a y coordinate of 20. It's way up here. There's a y coordinate of 1,000,000. I just have to go really far over. But every y coordinate is also associated with this graph. It will be found on this graph. So the way in math that we say this is it's this notation right here, x, such that x is an element of the real numbers. X is any real number, any number that's on this number line. This is the way to say it. Okay, so x is an element of the reals. But this is a problem here. This doesn't match what we see in our graph of our function. This says y such that y's are between -6 and 6. There's a more formal way to say that, but that's kind of what's going on here. Is that what's going on here on our graph? Do we only find y values between -6 and 6? No. No. So that's not correct for the range. This one happens to be the correct answer for this one. So the domain is all reals, the range is all reals. And we could come up with graphs that make these true. We could come up with graphs of them, but let's go ahead and go through here. These questions are really, really simple to answer. Is the relation represented in this table a function? Well, remember, the only thing that we really needed was every element from the domain, normally we call it x. So I'll say every x has only one y coordinate that it goes with, has only one y coordinate that is paired with. So let's take a look. I have -6 is paired with 5. So graphically, -6, 5 is a point on this graph. -4, 5 is also a point on this graph. -4, 5. Does that break it? Well, there's two values. Oh no, this doesn't break it because every x has only one y coordinate. Does it say every y coordinate only has one x value? No, no. Every x only has one y coordinate. Let's look at this one here. X is 0 is paired with 3. So 0, 3 is on the graph, and 2, 3 is on the graph. 2, 3. Again, we have that issue where we have two y coordinates that are shared by different x coordinates, but this doesn't break it. And then 4 zeros on the graph. This point down here is also on the graph. Notice I didn't connect the dots. I don't know if they should be connected. Did any x value have two y values or more that it went to? No. So this is a function. That's all it needs. Easy. How about this? So what I'm going to do is speed this up. I'm going to look at all my x's, see if there's any point that has that uses the same x. So -2, are any of these using -2? No. Okay. This one uses x equals 4. Does any other point have an x coordinate? Yes. This one here. So this is an example where when I plug in 4 for x, I get 5 sometimes. I plug in 4 for x, I get -4 sometimes. With a function, you have to guarantee that when I plug in 4, I only get one value. This is showing that 4 has two different values that it goes with. That's all you need. All you need is one point. You might have lots of points that break it, but really only one point is needed. This is not a function. If this one had said 4, 5 again, then it would be okay. That's just showing you an extra example of every time I plug in 4, I get 5. But this was showing us something different behavior. So this is the problem. These 2 points, if I were to graph them, 4, 5 would be here. So 4, 5, and then 4, -4. So the same x coordinate goes to two different y coordinates. That's bad. It's not a function. Okay, now let's take a look at some graphs. We have this one. Do we have the same behavior anywhere? Let's look and see, are there any points that have the same x coordinate? I'll see, because if I can draw a vertical line here at -8, if this vertical line crosses at two different points, that would be bad if we were looking for a function. This one here, no, that's okay. This one, there's no other point. No other point, no other point, no other point, no other point, no. So this is good. Good. Every x coordinate, only one y. Only one y. How about here, this graph? Oh, actually, we got lots of problems here if we're hoping for a function. This, when x is -1, it looks like it goes either to 2 or to -2. When x is -2, it looks like it goes to 3 or -3. When x is, you get the idea, there's lots and lots of points. If you were to make a vertical line here, so this is what's called the vertical line test. Choose any x coordinate and you draw a vertical line forever up and down. If your graph crosses it more than once, this one crosses it twice, it's not a function. No. Vertical line test. Okay, and we'll do the last section in just a bit.